Okay, we're all good? Okay, thanks everybody. Today's talk is going to be, or my talk anyway, is going to be about the JavaFX Canvas, but also, maybe you'll guess from the title a little bit about Java 2D, because that's my background. I'm going to start easy. This is a pixel. When I was young, that's what they looked like. My first computer was a ZX81, so that was what pixels looked like. This has no CSS styling. It's maybe not so interesting, but it's a good point to say if I do lose anybody as I go along, you can ask questions during the presentation. Pixels get a bit more interesting when you have lots of them. Here we have 46 pixels, and also something I remember from when I was a bit younger. I'm going to change the slide because I know some of you are counting them already. Okay, after a while we got more and more pixels and things got more interesting. This was our first graphical user interface that I saw. It's actually, if you look it up on the internet, this screen, I'm not sure if it's an original Macintosh screen, but the resolution of that is smaller than an icon on your iPhone. So also look that up on the web. It's all just pixels in the end. This is what I say sometimes at work, whenever we're looking at complex problems on the screen, on the systems. I just say, look, it's all just pixels. And for me, I think it is. So. Pixels aren't that new, pixel images anyway. There's one here from Roman times. I just put it up there because I like it. It's one for Garrett. Actually, I'm pretty sure the guy that made this probably just said, yeah, I just make these for fun, I don't use them myself. Okay, I'm going to take a quick diversion because I know Dirk was interested in real use applications, and I didn't join in that thing, but in my day job, here's an application that I work on. We don't really talk about the technology, but you might be able to guess. If you have a look on the link there, which I'll just switch over to now, there's a document on the web. Not this one, but this one. Okay, and let me go to the correct page. Not 83, sorry. Looking for 8. Okay, you might recognize in here. This is I work at Six Group, which is just a couple of blocks up the road. It's the financial infrastructure provider for Switzerland. They run the stock exchange. The program I'm involved in is a interbank trading platform. So we run some servers that let the banks trade with each other. We have a fat client UI. I won't talk about particularly the technology, but you can see here it has some interesting table component. This is one of the applications for dealing with reference data, the one that I showed you previously on the other slide. You can look through this document if you like. It is online publicly. It's used for the trader training exam. You can see the type of system that we're working on. So it's a real-life example of an application that could be using technology that we're interested in. I think it's not that we're particularly secretive about what technology we use. It's difficult sometimes to get somebody to authorize speaking about it. But have a look in the document and see if you can recognize some of the screenshots. Okay, that was the trader document. So, what is the JavaFX Canvas? I'm on slide 10 before I even started on the topic. The JavaFX Canvas you saw this morning in Garrett's talk, you can use it for controls. It's really just a node. So you have a look here in the, just up here, you can see in the Java docs, the canvas is just a node. It's a square or rectangular block of pixels. It's all just pixels. The API is very, very simple. You create a canvas with a width and a height. That's how many pixels you get. And it has a thing called a graphics context. And the graphics context is what lets you draw onto the canvas. I'm going to have a quick look at the graphics context, or what it does. It does 2D vector drawing. So there's all kinds of 2D vector drawing APIs in the world. They all do the same thing in the end. They draw and fill shapes, such as lines, rectangles, circles, Bezier curves, which are, I think Bezier is a French mathematician, or I'm not sure. But this is a way of defining a curve in terms of control points. And I think in the demos this morning you saw some people modifying control points and you saw curves changing. Those are Bezier curves generally. Also general paths, which is just a sequence of drawing commands through a path. These are the basics of vector drawing. You usually have colors with fills, gradient paints. Styling for lines, dashed lines, solid lines, whatever, all kinds of things. Important are the transformations. You can scale, translate, rotate, or apply any general matrix-based transformations to your two-dimensional drawing area. An important point is the text. You need to be able to draw text onto your canvas or whatever output you're doing. Something that seems to get quite often missed is the font metrics. So when you're drawing text, you need to be able to measure the size of the text so that you know exactly where to place it. And this is particularly important when you're doing, well, anything, but especially charts, which I've done some. There's usually some things there for drawing images, because images are pretty common. You can, as a source of things for putting onto a 2D drawing, so images are good. Clipping. You can clip shapes. We've seen some clipping in some of the other demos earlier. It's the same idea, clip to an arbitrary shape. That's a general kind of overview of what a 2D vector graphics API should do. So now let's have a quick look at the graphics context API. And if you look in here, I've just taken a clip from the Java docs. We don't have to read all of it, but you see at the top there's an attribute there for the clip. A little bit further down there's a transform. I was going to point with this, but I think I can't aim very well. A little bit further down, you'll see in the fill attributes, the fill paint, and the stroke attributes are stroke paint. These are colors, generally, gradient paints or just plain colors. You've got all the line attributes, line widths, line caps, various dashes, dash offsets, just attributes for drawing. On the next screen, we see some of the API methods for drawing. Okay, and if you've done any work with the HTML5 canvas, I think you'll recognize these methods. Personally, I think they're a bit of a mishmash. I don't like the API that much. You've got for me, stroking, like stroke is to draw an outline, to stroke a rectangle versus stroking a round rectangle. These are the same operations on different shapes. We'll see later how Java 2D treats that a little differently. But in the end, you have methods to draw these 2D shapes. You have some for text, a little bit dodgy on the font measurements, but we'll see that later, or I'll mention it. And down the bottom here we have the path rendering, so general path stuff, and I think the transformation, not so many obvious methods here, but there was a transform attribute at the start. Okay, so why is it that I'm interested in JavaFX Canvas? So I have to go back in time a little bit, and you'll see here, this is one of my projects from a long while ago. I started this in 1999. So 19 years ago. I'm going to give you a quick demo of the Swing version of this project, just for context if you haven't seen it before. Okay, here it is running in Swing, just a chart with some normal distributions. This is, I'm trying to remember now, JComponent or JPanel. There's zooming stuff here. You can zoom in and out. You can resize these things. It redraws itself. I think there's tooltips in there somewhere if you land on the right point, maybe not. There are some, there's one. There's right-click menus, you can copy the thing, you can print it, you can save it as an image or an SVG, whatever. So this project that I was working on for a long time has been very popular. There's a lot of people out there using it, and when JavaFX came along, they said, when are you going to port it to JavaFX? So I looked at that and thought, how would I do this? So let me go back just to my presentation. So if you look at the JFreeChart design, we won't need to focus on it too much, but the idea is that you take some data, and the data could be anything. It could be an arrays, it could be some list of values, primitives, number objects, or some custom structure. So I decided in JFreeChart to just put an interface or a set of interfaces in front of that and let people deal with the details behind. So JFreeChart will just read through dataset interfaces the minimum data it needs to plot some charts, and then ignores the rest. You then configure a chart with a title, a legend, a plot type, because there are a few different plot types, a renderer, which can change the appearance of how you plot data, and some annotations if you want to. And then when it comes to drawing the chart, JFreeChart looks at this object called And then based on the implementation of this, it outputs to Swing, to the panel which we saw before. Some other stuff, there's a bunch of things, PDF, SVG, PNG files, JPEG files. But the one we're interested in is JavaFX, in the red there. So that's how JFreeChart works underneath at a high level. You can always look through the code if you want to know more. Just some background on Java 2D and Graphics 2D. It was part of Java SE 1.2 in December 1998, so this was new when I started working with it. Graphics 2D is the focal point for this API. I think of it as an interface, but in fact it's an abstract class, but it just has a set of methods. I can't remember how many, maybe 45 methods that make up the API. There's, as I said, many implementations. An important aspect of this API, and what I think, I'm a big fan of Java 2D, what I think makes the API really work is the shape interface. Just a bit of a quick overview. I'm looking here at the Graphics 2D API. A bunch of methods, as I was saying, maybe about 40, can't remember. The third one down there, drawing a shape. Okay, this is the one that draws an outline of a shape. But the shape is an interface, so this can be any shape that you want. So we don't have a draw rectangle and a draw round rectangle and a draw circle and a draw line method. We just have one method. This is nice. There's a method a bit further down for drawing images and drawing strings, but the draw shape one's the main one. Second one on this slide is the fill shape. So this one takes the same shape and fills the interior with a color or a gradient paint or whatever you want. Fill 3D Rect, you can ignore. This is there were some leftovers from the AWT classes from 1996, I think, that they kept for backwards compatibility. Not important. There's a font rendering context there, which is useful, the one that's used for getting the font metrics. I think Java does a pretty good job of providing font metrics. I think it's maybe not 100% perfect, but I haven't seen another API that does it better so far. There's some stuff about the transform down the bottom there, some rotate methods, which actually the get transform and set transform are the only ones you need. The rotate, I think there's scale and translate are convenience methods, but they all map to the other ones. You have a set paint, so paint is also the sort of abstract representation of colors, gradient paints, radial gradient paints, whatever. And as I said, the transform. So this is this is pretty much the Graphics 2D API. You can look through that online or in a book. The shape interface, I just want to point out one method in here that's super important. Given a shape, you can get, there's a method called getPathIterator. And this method, no matter what the shape is, it will give you an iterator over a path that outlines the shape. So you can have absolutely any shape you want. And that means when you're implementing the Graphics 2D API, it doesn't matter what kind of shape somebody passes you, you have a way of getting its outline. And you can't do this with the JavaFX shapes, as we saw earlier. You can't do this in Android. You can't do this on the HTML5 canvas. I'm trying to think of a library where you can do it, actually. I think the Java 2D API is probably as good as it gets from 1999. This is the book that I read when I started this. I think this was published in probably 1999. It's still a good book. I don't know if it's in print anymore. But that's got a good coverage of pretty much everything you need to know if you're interested in Java 2D, as I was. Okay, so Java 2D came along in December 1998. The JavaFX Canvas in August 2012. So let's just revisit the graphics context API for a second. For recall, you see this ugly fill rect, fill round rect, fill oval, fill arc. If you're a web developer, maybe this is cool, but for me it's ugly. And I thought to myself, am I going to go through 600 JFreeChart classes and find every Java 2D call and map it to this stuff? I wasn't. This was when I realized that the canvas had no Java 2D, I was thinking, what were they thinking? I can think of some good reasons, but not many. So, what I decided was maybe it's possible to take the Graphics 2D abstract class and map the methods from the sensible Java 2D API methods onto the JavaFX Canvas. So I did this specifically for JFreeChart, but it's a very general purpose thing. You could use it for any Java 2D code. I made it a BSD style license because I thought this would be, it's not a big class, it's not a big library, and I thought it would be very useful. So BSD style license is very liberal, open source. It's kind of like take it and do what you want. It's on GitHub. It's done a few versions. I think apart from some small text, like as I was mentioning before, the font metrics are not ideal in the canvas. So sometimes some text layout doesn't work well, but everything else looks pretty good. So how does it work? You probably guess already from my description. You take a graphics module, which can be anything Java 2D based. So JFreeChart. Another library I'll show you shortly, Awesome Charts, which is a 3D library. I did this with a library called JLaTeX Math, which is a library Java 2D library for doing maths formulas graphically. I've done it with a barcode library I found. But also if you have Java 2D code in your existing applications that you need to port, you could use this approach. So you've got a graphics module on the left. It's targeting the graphics 2D API, Java 2D. You pass it the implementation of FX graphics 2D, and it keeps on calling the same API, but it remaps them onto this JavaFX Canvas graphics context. And as I was saying, pretty much in the end, it is 2D vector drawing, so there's usually a good mapping. And so your Java 2D code ends up drawing on the JavaFX Canvas. Let's have a quick look in NetBeans. I use NetBeans. Not always a popular choice, but okay. So at the top there is the project for the FX Graphics 2D. There's just 5 classes, but the main one is that FX Graphics 2D. It's about 2,000 lines of code with comments, so it's not a huge amount of code. Just to give you an example of what I do in the draw shape method, which is probably one of the most important or most often used. We just comment there. We look at the current stroke that's been set. This is a Java 2D thing. It is possible to write a custom stroke implementation, and when people do that, it gets hard to map onto something like the canvas. But luckily, there is this create stroke shape idea, which creates a custom shape with a path iterator, which we then pass back into the fill method, and we fill the outline of the stroke. It's very, very general. This little trick at the front has made some, not my code, but some other people's code work, which was good. Then inside here, there's certain kind of optimizations I've done just by looking at what kind of shape we get past. We get past a line, we can just call whatever that stroke line one method was in the canvas. And if we get a rectangle 2D, we can just call the canvas method to draw a rectangle. And as we go further down, we get to the last one, we just create the shape as a path, and then we render the path. So in the end, with this code and a few other little tricks, we can take the Java 2D code and render it in the canvas. Okay, this is on GitHub. I think I left the link there before, so feel free to go through it. When I first did this library, I wrote a Java magazine article. It's hard to find online now. I'll go just quickly show you this. It's this one here. So it's described as a bridge from Java 2D to JavaFX. It's describing more or less what I'm saying here. You have an example here of a chart in JFreeChart running in JavaFX. I did a little bit of stuff in here. Up in the top right, you can see the library I mentioned, JLaTeX Math. So just a small maths formula that if you want to put some of that in your UI at some time, you can do this. By reusing a library that is written for Java 2D, you can make it run in JavaFX without problems. The listings, just some examples in there. The chart here is Awesome Charts, which I'll show you in a minute, assuming that there's still plenty of time. What I did also in this article was some performance measurements, because I was interested to know whether the JavaFX Canvas performed better or worse than the Java 2D implementation on JComponent or JPanel. What I found when I ran, when I researched on the internet, it was generally, there wasn't a lot of info. It was generally shown that the Canvas and the Java 2D implementations were more or less the same speed. In my tests, I took the chart that you saw on the previous page there, this one, rotated it around so it got drawn lots of times. I think I redrew it 1,000 times or something. It's a software renderer. And I think in JavaFX it was 18.4 seconds on average, and Swing it was 17.4. So it was fractionally slower with the FX Graphics 2D, but probably if you take into account the overhead of redirecting the API calls, it's more or less equivalent. So I think no big performance hits to do this. Okay, so the 3D chart thing that I showed you, this was another example. I need to be slightly careful here. JFreeChart as an open source library is LGPL, so most people can use that in their applications as they wish. Awesome Charts, I use the GPL, which people do not like so much. I have a commercial license separately, but just as a forewarning, the code is open source, but it's one of the less liberal licenses. There's two modules here on GitHub, the Awesome Charts, which is the base library. This is Java 2D based. It has the Swing components in there, but nothing for JavaFX. The Awesome Charts FX just adds a chart viewer component, which has a canvas with the FX Graphics 2D as a dependency. So it's kind of nicely separated out that if you are using JavaFX, you can just grab the extra library, which is small. If you're just using Awesome Charts for Swing, you can stick with it. In terms of the design, you might recognize this is exactly the same setup as JFreeChart. We take some data, which can be whatever you want. We hide it behind some interfaces. So I provide the interfaces and some default implementations if you want it to be easy. But if you have your data in a certain structure, you can just implement the interface and then the chart library will take it from there. You set up more or less the charts the same way as in JFreeChart, only there's a focus on 3 dimensions. It's software rendering for 3D, I think I mentioned already. And the focus is a little bit business charts. So for those of you that like scientific charts, I think you might not find it so interesting. Maybe some of it, but not all of it. Graphics 2D again as the target, and again the same outputs. Swing, JavaFX, JPEG files, PNG files, PDF, SVG. The demos for Awesome Charts are on GitHub. Slightly different to JFreeChart. JFreeChart, you can go grab all the code and run it. The demos I sell with a developer guide. But with Awesome Charts, because I have the commercial license, because it's GPL, there's no real incentive to keep the demos behind, so I don't. Let me see what's happened here. I need to run it again. So the JavaFX demos here that you'll find on GitHub, there's a few for JFreeChart, just a couple. The main one here for Awesome Charts. Okay. On an old version of Java. Okay, so as I was saying, these are business style charts, so pie charts that you can scroll around. I think this is the JavaFX Canvas in the background. I've implemented tooltips, so I think it was mentioned this morning that you have a single component, so you have to do all the mouse handling yourself. So we track on these charts all of the areas that need, if you want to display a tooltip, you need to know where the mouse is and what's underneath it. That's all tracked. It's resizable. Actually the 3D part is less resizable, but it can zoom in and out, so no problems. There's a few different types of charts in here. This one is, as I say, it's a software renderer, but there's 2,000 points in here, and you can scroll it about. It's not horribly slow. We keep all of the data, so you can still get tooltips for each data point. I was watching a demo this morning with you guys on the Workbench FX. So for this little demo, I did my own little tabs and things, and I was thinking this is painful. I am planning to switch this over to use the Workbench FX, so I think that was a really good presentation this morning. Zooming in and out here. There's a few little features in here. This is a logarithmic axis, or I can switch it. We're upside down now, so it's a bit funny, but switch the axes around. There's various things in here. I think what was the one I was showing you? This is the one that I did in the performance demo before I set up a loop that just set there rotating this thing, so it would just keep on redrawing. The software rendering is just as simple. If people know this stuff, it's the simple painter's algorithm, so you can get some funny artifacts happening sometimes. Somebody asked me if I would try doing these charts either in Swing with OpenGL or something. I had a look at it once, and the bit that was getting me was how to get the text placed on the chart. So I ended up not having time to do that. So there was one other thing in here I was going to show, but I forgot what it was. Oh yeah, maybe. No, it wasn't this one. Okay, I forgot. Okay, so this is the Awesome Charts demo. GitHub link here. Everything now on Maven. This is just the JLaTeX math thing that I mentioned earlier. On this one, I didn't put a URL. I think Google it. It's very easy to find. Otherwise, it's in the article on the Java magazine. Okay. Just a little bonus. I mentioned before about the Graphics2D and how you can get various output types. I wrote a library. I used to use a library called Batik, which is an Apache library, I think, to output to SVG from JFreeChart and Awesome Charts. People were contacting me. Batik is a really good library, but it's focused on SVG rendering, actually, taking SVG and just showing it on the screen. They have a Graphics2D implementation going the other way, taking Java 2D calls and writing SVG output. But the dependencies that you have to take in for that are quite painful, and people are saying, they kept asking me which jars, because I think Batik comes with, 9 jar files, and you need 6 of them, but they don't say which 6 you need. And I thought this can't be really that much code to do this. So I sat down one day and, for fun, made this SVG implementation. And actually, I really enjoyed this one. I think when you output the charts to SVG and then look at them in a browser, for some reason, the rendering is nicer in the browser than in Java 2D. Just same vector graphics, but the result looks nicer, certainly than Java 2D anyway. But wait, there's more. After I did that one, I thought, well, I also like to output to PDF, but the PDF Graphics2D implementation that was out there was part of the iText library. And that one also is a big, in terms of size, it was like 1.5 megs to get just PDF output. So I wrote this one. It's also GPL, but it renders to PDF, and the library is, 40K or something. It's quite small. The PDF spec is not so nice, though, to look at. Okay, so Dirk's going to be very happy because I'm almost done. Hopefully I'll have some time for questions. Just to recap, it's all pixels, all just pixels. The canvas is a JavaFX node, as we know. There's some very cool Java 2D code out there. As I mentioned before, not only the LaTeX math one, there's some barcode readers and QR code stuff, which was nice. Charts if you need chart options. And I think out there's also people with in-house apps that have written in Swing that have Java 2D code. I think potentially for porting efforts, they could benefit from FX Graphics 2D. So, and that's my sense of supercharging the canvas. I hope somebody didn't think it was that I was going to make it 10 times faster or anything like that. And as a bonus, when you use this in your JavaFX application, you get the other outputs like SVG and PDF for free. If you don't like the licensing of the smaller libraries I've written, there are alternatives. Batik, as I mentioned, is an Apache project, so you get SVG from them for a larger dependency, but freer licensing. PDF, I think I forget the name of it. There's iText, and there's a third one that does PDF, also with a Apache style license. So, does anyone have questions? Garrett. Not really, just the interactive stuff that you can do. I think we saw. If you update the data model, it's like JFreeChart. It fires a data set change event that goes through to the chart, and the chart just repaints. This is the main problem that people have had also with JFreeChart. Is in terms of animation, it's really just a full repaint of everything. So it works. I mean, the mechanism works, but in the end, you are churning through CPU. So there's other ways of doing that faster, but not in a general way. You need to do some tricks. Yes.
There was one point I didn't understand when you mentioned that if you have implemented your own stroke type,
Yeah.
will it work or will it not work?
Yeah, initially when I implemented it, didn't, but there's a method that takes, you can write a custom stroke implementation, and there's a method that will then take that implementation and create an outline of the stroke shape. And once you have an outline of the stroke shape as a general path, you can then...
That's what the interface of the stroke says. Do exactly that.
Yeah, and then you pass that back into the FX Graphics2D and just fill that general path. So instead of stroking a line, you now fill... No, you implement the stroke yourself, whatever custom stroke, and when you use that, automatically FX Graphics2D will convert that to an outline and fill it. Yeah. So somebody sent me some code that they'd written that wasn't working the way they wanted, and they gave me a good demo, and I looked at it and I thought, well, this is the easiest solution, and it works really well. So. Okay, no more questions? Oh, one.
Text layouts. You said you had some difficulties. Can you use it at all, or it's kind of...
What I've done, the initial implementation, the only way to measure text seems to be to create a text node or something, render it, or not render it, but just create it, and then look at the width and height, and that's the best you get. When you're doing, in Java 2D, you can get a lot more detailed information. You can get the baseline, you can get the ascent, the descent, lots of data. And when I was doing the charts, I found that if you want to align some text to the tick marks, it's not really the center that makes it look right. It's the center of the, you have to take the baseline and things into account. And with the FX Graphics2D, sometimes you'll see that the text looks sort of slightly off. But in general, it's not too bad. There was, I did implement something recently which gives you an option for something that's, I think it's a internal API, so you probably shouldn't use it, but I made a rendering hint that you could switch to that if it made the output look better, which it does in one of the JFreeChart demos. So, but that will fail after Java 8. So. Okay, thank you very much.